Let's go through the study guide as a way to make sure you're prepared for the test. Question 1. Is this a function and is it linear? So remember that you need to check both parts, the word function and the word linear. In order to be a function, it has to pass the vertical line test. So you can draw your line down. See how it only hits one time? The x cannot repeat. It's only hitting one time. So this makes it a function. Is it linear? In order to be linear, it has to be a straight line with no curves. So it is not linear. Therefore, it is not a linear function. Question 2. It passes the vertical line test. It only hits one time. Is it linear? Yes, it makes a straight line. So it's a function, and it is linear. Therefore, it is a linear function. Question 3. Is this a linear function? So again, to be a function, you have to see if the x repeats. So I look across my x values, and I notice that the x is not repeating. So this is a function. In order to see if it's linear on a table, there has to be an adding and subtracting pattern in the x and the y. So in the x, notice they're all adding by 1. So that is an arithmetic sequence pattern. But in the y, this one goes down 3 and then up 4. Already that is not linear. It has to have an adding and subtracting pattern in the x and the y, a constant increase or decrease in the x and the y. So this is not a linear function because it doesn't have that arithmetic sequence pattern. When you look at equations to see if those are linear, they can't have an x squared in it. Remember in the last test, if there was an x squared, it made a quadratic, a parabola. And it can't have an absolute value, like x minus 4 or something like that in the equation, because absolute value, v, created a v shape in the graph. So we need it to have no x squared and no absolute value. So this one has x squared, so it's no. This one doesn't have either, that's a yes. Okay, looking at question 5, to find the x and y intercepts, we're looking for where it hits the y-axis. Here's your y-axis, it's hitting at 2. So the y-intercept is 2, or in ordered pair form, it would be 0, 2. Notice that the x is 0 when you have a y-intercept. And for the x-intercept, it's intercepting at -3 as an ordered pair. That would be -3, 0. Again, notice that for the x-intercept, the y value is 0. That's important for the next type of problem. In question 6, when you're given the equation, and you have to find the x and y intercept, that's when you know that if you have an x-intercept, if I'm finding the x-intercept, for instance, I know that the y value is going to be 0. So this whole area, the -2 times 0, is just 0, so we are allowed to cross that out. So I end up with an equation that looks like this. 0 equals 3x minus 6. Then I solve that like I normally would, just to solve for the variable. So I add 6 to both sides. That gets me 6 equals 3x. Divide by 3 to both sides. X equals 2. That is my x-intercept, is 2. As an ordered pair, it would be 2, and then the y is 0. Okay, now for the y-intercept. I'm going to take the same equation, which was, let me go back and make sure I have the right equation. Oh, I would not have. The -2y. Okay, so the -2y equals 3x minus 6. But since I'm finding the y-intercept, think to yourself, which one's going to be 0? For a y-intercept, the x value will be 0. So if I plug in 0 here, 3 times 0 is 0. So I'm allowed to just cross all that out. And so now I have negative 2y equals negative 6. Solve for y. Divide by negative 2. And you get that y is 3. Remember, you could put that in as an ordered pair. If the y value is 3, then the x value would be 0 because it was a y-intercept. And you can graph those. So 2, 0 is on the x-axis because it was the x-intercept. 0, 3 is on the y-axis because it was the y-intercept. Then you could connect these to form a line. And it says, is the slope positive or negative? So when reading from left to right, this would be me skiing downhill. Negative. Okay, for rate of change, it says for this question, find the rate of change for each time period. We have x and then y. Rate of change is change in y over change in x. If you don't know that symbol, you have to write the words change in y over change in x. Okay, so the change in y for the first interval is 0. The y value is not changing at all. The change in x is going from 2 to 3, so that's a change of 1. Remember when 0 is on top? That's okay. The answer is 0. Change your color. Go to the next interval. We're going to do it again. Change in y over change in x. You end up getting 7 for the change in y from 56 to 63. And from 3 to 5, it's 2. If you want that in decimal form, you can. It's 3.5 or 7 over 2 is fine. Change your color again. Change in y. 8 over 63 to 7 one's 8. 5 to 7 is 2. 8 over 2, which simplifies to 4. And then our last one, I don't know if I have another color option here. I'll do black. Change in y over change in x. From 71 to 72 is 1. From 7 to 8 is 1. And the question says, during which time period did the temperature increase at the fastest rate? It increased at the fastest rate for the number 4. So which time period was that? That was my green. I didn't circle the other green. So let's just take a look at that. So it was the green time period, which is month 5 to 7. Okay, finding slope. Since it's on a graph, we have two options. We can use just rise over run if we want, where you count up 1, 2, 3, 4, 5, 6, and over 2. Literally 6 over 2. Slope is a fraction, like the change in y over change in x. Rise over run. y2 minus y1 over x2 minus x1. So 6 over 2 is 3. Now, if you took those two ordered pairs of those points, we have 1, 3, and -1, -3. And we're going to do x1, y1, x2, y2. My first order pair, my second order pair. And I'm going to use the slope formula, which you need to have memorized. We get -6 over -2, which is 3. I want you using two ways on this test to find slope. So it's a great way to check. Okay, this is review. I'm going to go through it quickly. You guys learned this last year. x1, not x2. Don't do that on the test. That's what people keep doing. It goes x and then y every time. So it's x1, y1, x2, y2. Maybe I shouldn't go quickly. y2 minus y1 over x2 minus x1. Notice I start with the formula. 4 minus 7 over 4 minus 2. Negative 3 over 2. And you can leave your answer just like that. You can graph it and check the rise over run and make sure it's actually a negative slope. Multiple ways to check. I've got my formula again for the next one. x1, y1, x2, y2. Negative 5 minus negative 5. Be careful of that. The negatives throw people off. 6 minus negative 9. There has to be that minus in between because that's what's in the formula. You can change these right away since you guys are good about that. Negative 5 plus 5 is 0 over 6 plus 9 is 15. 0 on top is 0. Remember, if we ended up with 0 in the bottom, if this happened, this is the one where it's undefined on the slope. If that were me skiing, I don't know what would happen, so it's undefined.